Okay, this is problem number 67. A steel cable zip line is being constructed for a competition on a reality television show. One end of the zip line is attached to a platform on top of a 150-foot pole. The other end of the zip line is attached to the top of a 5-foot stake. The angle of elevation to the platform is 23 degrees. A, how long is the zip line? B, how far is the stake from the pole? And C, contestants take an average of 6 seconds to reach the ground from the top of the zip line. At what rate are contestants moving down the line? At what rate are they dropping vertically? So once again, I'm going to sketch me a picture here, even though I'm given one. So this is going to be the height of my pole. This is going to be the height of the stake. Now the stake is 5 feet. So over here, the pole itself is 150 feet tall. So this is 150 feet. But the stake comes up this high on the pole. So the distance I'm concerned about is 150 minus 5. So that's going to be 145 feet. So the zip line will go this way. It will start 150 feet high and it'll stop 5 feet off the ground. So here's my zip line. The triangle I'm going to use to work the problem will have this for a base. Now this is my angle theta, this is my 23 degrees. So relative to theta, this is going to be the opposite side. This will be the hypotenuse, and this will be the adjacent side. So I know that theta is 23 degrees. I know the opposite side is 145 feet. And I know that the hypotenuse is the zip line. So part A says, how long is the zip line? Well, as I said, the zip line is the hypotenuse. So I'm looking for hypotenuse. I'm given opposite. So my relationship is going to involve the opposite side and the hypotenuse. And by definition, this is the sine of theta. So let's solve part A. The sine of theta equals the opposite divided by the hypotenuse. So the sine of 23 degrees is equal to the opposite side, 145 feet, divided by the hypotenuse. I need the hypotenuse, so I have to solve for this. If I multiply both sides by the hypotenuse, I get hypotenuse times the sine of 23 degrees equals 145. So the hypotenuse is equal to 145 feet divided by the sine of 23 degrees. And I can work this out with the calculator. Now once again, the calculator has to be in degrees, so I'm going to double check that. And you can see it's in degrees. So 145 divided by the sine of 23 degrees gives me a length of 371.1 feet. So I can answer the question. The zip line has a length of 371.1 feet. That's part A. Now let's go to part B. Now part B, here, take a look at part A before I get too far away from that. Okay. Now part B, I want to find how far is the stake from the pole. Well, from the stake to the pole is the adjacent side. So now I am looking for the adjacent. I still have the opposite. So I have a relationship, the opposite over the adjacent implies the tangent of theta. So that gives me the tangent of 23 degrees is equal to the opposite side, which is 145 feet, divided by the adjacent side. Now I need the adjacent side, so I'm going to multiply both sides by adjacent. Divide by tangent, and I see that the adjacent side is just 145 feet divided by the tangent of 23 degrees. And that turns out to be 145 divided by the tangent of 23 degrees, 341.6 feet. And now I'm going to answer the question. The stake is 341.6 feet from the pole. Okay, that's part C. Part B, rather. Let's go to part C. Part C says contestants take an average of 6 seconds to reach the ground from the top of the zip line. At what rate are contestants moving down the line, and at what rate are they dropping vertically? Well, the rate is just the distance divided by time. And we're given time in this case to be 6 seconds. So I'm going to go back to part A. The zip line has a length of 371 feet. So the rate is that distance, 371.1 feet, divided by the time, 6 seconds. So this turns out to be 371.1 divided by 6, 61.85 feet per second. Now answer the question. The contestants are moving down the zip line at 61.85 feet per second. Okay. Second part of that is at what rate are they dropping vertically? Well, the height is given as 145, so the vertical height is 145 feet. And the time, again, is still 6 seconds. So the rate is 145 feet divided by 6 seconds. So using the calculator, we have 145 divided by 6 gives us 21.167 24 rather, not 21, 167 feet per second. Now we answer the question. The contestants are dropping vertically at 24.167 feet per second. Now let's take an overall look at the problem before I stop this. Okay, that's part A. And this is part B and C.